and subtracting in scientific notation. So we've looked at numbers in scientific notation and we've changed them to standard form. We've taken standard form and we've changed them to scientific. Now let's work just with scientific notation and perform some operations on them. So we're going to start with adding and subtracting. So to add or subtract two numbers in scientific notation, first step, if necessary, rewrite both numbers with the same power of 10. And then second step, add or subtract the factors, keeping the same power of 10. So whenever we add or subtract, no matter what it is that we're adding or subtracting, we can only add or subtract things that are alike. So if you remember to our variables, if I have 2a and 3a, I can add those together. I'm going to add the 2 and the 3 and get 5, and that's an a because they were a's when I started with them. Same thing with subtraction. So here, when we work with scientific notation, same thing applies. When we add or subtract, we need things to be alike in order to add or subtract them, and then we're going to keep the reason that they're alike. We're going to keep what makes them the same in the first place. So let's see how this works. So find the sum or difference, write your answer in scientific notation. So we're going to start with 7.8 times 10 to the negative fifth plus 4.5 times 10 to the negative fifth. So you notice that these are both 10 to the negative fifth, so they're like terms. I want to think about them that way. So what I'm going to do is I'm going to add my factors that are at the front, and I'm going to keep the power of 10. So I've got 7.8 plus 4.5, that gives me 12.3 times 10 to the negative fifth. Remember, for here, these are like terms, so the reason they are alike, I'm keeping that when I add them together. I'm going to keep that 10 to the negative fifth power. I'm just going to add the factors that are in front there. So I'm not doing anything with these powers of 10 when I'm adding or subtracting. I just need them to be alike in order to do the addition or subtraction. So here you'll notice we have 12.3 times 10 to the negative fifth. Our answer needs to be in scientific notation, and this is not in scientific notation because 12.3 is not between 1 and 10. It's larger than 1. So now I need to get a little fancy here, and I'm going to change this number that kind of looks like scientific notation into actual scientific notation. So here's what I'm going to do. Here's how I rewrite a number into scientific notation. So the first thing I'm going to do is rewrite the factor in scientific notation, and I'm going to ignore that power of 10 for the moment. So I'm going to ignore this power of 10 here at the second, and I'm just going to mess around with the 12.3. So imagine that this was just a case of, I've given you 12.3, write it in scientific notation. So it's a number that's larger than 1, so I know it's going to be a positive exponent on here. I'm going to move the decimal so it's between the 1 and the 2, so I end up with 1.23 times 10 to the, I moved it one place, so it's to the first power. Okay, so this is just what we've been doing up until now. After I've done that, and now this looks like scientific notation, I'm going to bring back the times 10 to the negative fifth that I had a minute ago, and now I'm going to leave the 1.23 alone. I'm going to keep the factor, and I'm going to multiply the two powers of 10. So I'm going to keep that factor there, and now I'm just going to mess around with my factors of 10. 10 to the first power times 10 to the negative fifth power. You'll remember that if I'm multiplying powers that have the same base, I can add their exponents. So I'm going to do 1 plus negative 5, which gives me negative 4. So this is my first step in changing it to scientific notation, and this is my second step in changing it to scientific notation. So I end up with 1.2 times 10 to the negative fourth power. Okay, so we started out by just adding, making sure that our powers of 10 were the same. Once we added, we realized this wasn't scientific notation, and I needed to do a little tweak to turn it into scientific notation. All right, let's take a look at some subtraction here. So I'm going to do 8.2 times 10 to the second power minus 3.41 times 10 to the negative first power. Now you'll notice that these powers of 10 are not the same. So I can't subtract them the way they are because they're not alike. But I can, since it's scientific notation, change them so that they are both the same power of 10. Now that means that one of these is going to be in kind of that, it looks like scientific notation, but it's not really. So we'll have a power of 10, but the factor won't be between 1 and 10. But that's okay because we're kind of in the middle of our messy work here. So I'm going to take this second one here, and I'm going to try to get it to have a power of 10 to the second power. So what I'm going to do, I'm going to pay only attention to this 3.41 times 10 to the negative first power. So I'm going to ignore the 3.41 for the moment, and I'm going to try to figure out how do I get this 10 to the negative first power to be 10 to the second. So I'm going to have to break it up. I want it to be 10 to the second, and I want it to be 10 to the something that when I add these two together, I get negative 3. So 2 plus what is negative 3, is negative 1. 2 plus what is negative 1. I want the sum to be negative 1 when I add them together. So 2 plus negative 3 is negative 1. So I'm going to break this power of 10 up into 10 to the negative third times 10 to the second. So I'm going to rewrite the power of 10 as the product of two powers that equal the original power, and I'm going to ignore the factor for now. So I'm ignoring that 3.41. So again, if I backtrack here, 10 to the negative third times 10 to the second power, if I combine those together by keeping the base and adding the exponents, I'd get 10 to the negative first power. So 10 to the negative first is the same as this here, except you'll notice that I've got this 10 to the second, which is what I was aiming for. I want to try to keep that 10 to the second in there. I want them to both be 10 to the second when I'm done. So my next step is I'm going to keep the power that I wanted, and I'm going to multiply the other power by that factor. So I'm going to keep this 10 to the second. I'm going to hang on to that for a second, and I'm going to do 3.41 times 10 to the negative third. So just imagine here that I said change this to standard form. That's all we're doing. I'm going to move the decimal 3 places. Since this is a negative exponent, it's going to be smaller than 3 when I'm done. So I'm going to move the decimal to the left. So I moved it 1, 2, 3 places to the left and got 0.0341 times, and here comes my 10 to the second. So now that I've kind of messed around with my second number, I can bring back in that first number that I was trying to subtract from in the start here. 8.2 times 10 to the second minus 0.00341 times 10 to the second. So now you'll notice that I have two powers that are the same, which means I can keep that power, and I can just subtract these two, and I end up with 8.19659 as my factor, and there is my difference in scientific notation. So we've got a few things here going on. Adding and subtracting, make sure that your powers of 10 are the same. Can't add or subtract if the powers of 10 are not the same. And then we've also seen how I can change scientific notation into a kind of weird looking, not scientific notation with a power that I want. And we've also looked at changing a number that's kind of scientific notation into a number that is actually scientific notation. So it was a lot here today, and we'll practice that.